Okay, and the final part of this session are the shiftings. I'm going to take this equation. So this is really what they want me to do. They want me to figure out everything about this. This is how I'm going to do this. They write it this way because they write formulas in the book. We don't do that. Divide by -4. And I could say y equals x plus 1 squared over -4 plus 3. So the way we're going to do this, they want us to find the vertex, focus, and directrix. The way we're going to do this, we're going to actually do double the work. We're going to ignore the shifts. And I know this is a lot of work, but that's how we're going to do things, unless we're really comfortable with this. We're going to sketch a rough graph that they're not asking for. 0, 0, 1, -1/4, -1, -1/4. There's the graph. I'm going to label the vertex. The vertex for this graph is 0, 0. I'm going to figure out what the focus is. 1 over 4 equal 1 over 4p. It's negative. Plus multiply. -4p equal 4. That means p is -1. Again, negative significance of negative, it opens down. We already know that. Notice how they word things. They sketch at the last step. We do the opposite. The reason for that, they use formulas. There are 12 to 14 formulas in this section. We don't need any of them except the focus. So 1 unit down is the focus. That makes the focus 0, -1. And 1 unit up is the directrix, y equal 1. That takes care of it. All of that is not needed. This is what I need. Well, look how this is going to work for us. Now I'm going to graph it. And this is how I'm going to graph it. I'm going to go ahead and say the actual vertex is -1, 3. And what does that mean? Add -1 to all the x's, add 3 to all the y's. Take the x's, add -3 to, or -1 to them, take the y's and add 3 to that. Well, the new focus will be at -1. And if I add 3 to this -1, that's a 2. And if I have y equal 1 and I add 3 to it, that's y equal 4. And look how nice this would be. I have a vertex at -1, 1, 2, 3. I have a focus at -1, 1, 2. And I have a directrix at 1, 2, 3, 4. Even though it's more work, it's a lot easier to run this way than the way the book wants us to do all of these awesome things. So let's look at another. Number 42, we're going to do the same. We're going to ignore what they're saying. They want us to sketch a graph of this. Find the foci, vertex, and center. Plot the graph of the new ellipse. Well, guess what we're going to do? We're going to ignore the shift completely. We're going to look at x squared over 9 plus y squared over 25 equal a 1. So we're doing double the work. Again, if you're really comfortable with this, you don't have to do this. But if you're not, guess what? We're going to stretch 3 in the x, 5 in the y, we're going to do all of this extra work. What do they want? I have a center at 0, 0. I have vertices. Isn't the vertices along the major axis? Isn't that 0, 5 and 0, -5? And to find the foci, I'm going to take the larger minus the smaller. That's 4. There. Guess what? Now I'm going to look at this equation and say, you know what? Wait a minute, time out. My center is actually at the opposite of this and the opposite of that. So I'm going to figure out what all of these coordinates are. And by then I got everything that I need. And how am I going to do that? I am going to go to the x-axis and add a -3. If you add -3 to 0, doesn't that make all of these -3? and I'm going to run to the y. Instead of 0, I'm going to add a -2 to all of those. If I add a -2 to each of those, wouldn't that become a 3, a -7, a 2, and a -6? And now if I would go ahead and do what they want. First, I already answered part A clearly right there. And plot the point, guess what? I got everything that's needed. The center is at -1, -2, -3, -1, -2. And all what I have to do is mimic what I did there. Move to the right 3 units, 1, 2, 3, 1, 2, 3. Go up 5 units and down 5 units, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Connect those. There's the graph. And did you notice that something's not right? Yeah. Did you notice that? Actually, it is right. The focus was 1 unit away from. I could just label that without even doing any work. Everything's there already. Last problem we have is this hyperbola. Again, this is what they want us to graph. And what do they want us to label? They would like us to label the center, the foci, vertices, and asymptotes. All right, well, let's see how that works. Guess what? I'm going to look at y squared over 4 minus x squared over 5 equal 1. That's really what I'm going to graph. I'm going to do all the work on that. I am going to look at how does that graph look like and label everything that they want. They want me to label the center. I'm going to label the center. In this case, I'm going to assume it's 0, 0. That didn't line up properly. There we go. And they want us to label the foci. I'll get to that in a minute. They want us to label the vertices. I'll get to that in a minute. And the asymptotes. I'll get to that in a minute. So, if I look at that, I'm going to move 2 in the y and -2 in the y, radical 5 in the x, create my rectangular box, so all of this work, I notice the negative is in front of the x, so the graph looks like that. First things first, I know the vertices are 0, 2, 0, -2. That's very important, right? I know the rise is 2 units, and the run is radical 5 units. There. The only thing missing is the foci. Well, how do you find the foci? Isn't that the square root of 4 plus 5, which is 3? 1, 2, 3 units, and 1, 2, 3 units. Got it. Well, guess what? When I want to graph this, I'm going to say, look, the only difference, the center, this is still a 0, but this is a -2. So I'm going to copy all of those, leave the x alone because we didn't do anything to the x. And if we did, not a problem, I'll do it right there. And I'll get to this last part in a minute. So, and do you notice what we did to the y's? We're adding a -2 to all the y's. So 3 minus 2 is 1, -3 minus 2 is -5, 2 minus 2 is 0, and -2 minus 2 is -4. When I get to the graph, I really don't need to worry much about anything because I'm going to mimic what I did right there. All what I have to do is go 0, -2, and copy literally what I did, right? 2 units up, 2 units down, radical 5 to the right, radical 5 to the left. Copy what I just did. Even though this seems to be like a lot of work, it's worth it. And there's a song like that, isn't there? It's worth it. And since the graph is wrapped around the y, there it is. I already labeled the vertices. I need to, and didn't I go 3 above, or it's 1 unit above? I just label it and there it is. And look how this plays. When I want to find the equation of this, do you see what they replaced y with? And if they were to replace x by any quantity, I would just put it right there, and that'll do the trick. And there it is. Now, you don't have to do the left graph or any of that work if you're comfortable with this. Like me, I wouldn't do that, but you know me, all-knowing and all. I'm just kidding. On number 58, through the end of the section, find the center, foci, vertices, asymptotes, and radius. They don't want us to graph. Well, if you see two squares, it's either an ellipse, a parabola, or hyperbola. Since it's a plus, it's an ellipse or a circle. If those are equal, it's a circle. If it's a circle, there's an easy way out. I could divide by whatever that number is. By 2, not by 4. I'm so stuck on the radius. By 2, that's 14x plus 6y plus 57 equals 0. So I'm looking at x squared minus 14x plus y squared plus 6y equaling negative 57. I'm going to add a number to the x. I'm going to add a number to the y. Take half of the middle number, which is 7, and square it. Take half of the middle number, which is 3, and square it. I will be looking at x minus the number before I squared it, y plus the number before I squared it, and here I'm looking at 58 minus 1, which is 1. We would say this is a circle. Again, the other one is the graph. Graphing is the easy part, in which the center is at 7, negative 3, and we have a radius of 1. And that's how you do the rest of those. Complete the square, and there it is. Here's the homework. 1 through 8 is matching. You're going to do all of the matching. You don't have to do much work there. But 9 through 37, you could do the odd, you could do the every other odd. I don't know how much of this you remember. I don't want to force you to do that. But I suggest you definitely look at this set and do them for sure.